we're gonna see the acylation and alkylation of benzene. First, we're going to see acylation of benzene. In this reaction, we have benzene which is going to react with acyl halide, and acyl halide is basically carboxylic acid kind of thing, but over here instead of COOH, we have CO, the carbonyl group, and the carbonyl group is attached with a halogen. So this thing is known as acyl halide, or this one in this particular example is the carbon. We have two carbons, so it would be eth, right? So we're gonna name it as ethanoyl chloride. Okay, and this is going to react in the presence of FeCl3 or FeBr3 or AlCl3. These are all the catalysts that you can use in this reaction, and we're gonna get this product. Okay, and this chlorine over here is not going to be present anymore. We're going to have the carbonyl group, and this is going to be attached like this, and we're going to have HCl, which is going to be made up of the hydrogen, which has been removed from this benzene ring, and the chlorine, which has been removed from this acyl chloride over here. Now we need to know one more thing, is that C6H5, we do know that C6H6 is benzene, and we do know that, for example, in C2H6 is ethane, and if we remove one hydrogen, so it's C2H5, which is ethyl, or the alkyl group, right? In the similar manner, benzene is C6H6, and when we remove one hydrogen, we have an alkyl group, or we'll call it the phenyl. Okay? So this product over here, along with hydrogen chloride, is this ring will not be known as benzene anymore. It will be phenyl. And then this over here at this carbon, it has two groups on either side, and it has double bond attached with it as well. So it's kind of like a ketone, right? We have this thing, R, C, double bond O, R. So this is phenyl ethanoine. Why ethanoine? Because we have 2 carbons over here. And in this reaction, the electrophile is going to be this. We have CH3 bonded to C double bond O Cl, right? And then this chlorine is going to leave, right? It's going to leave. So we are going to be left with CH3 C double bond O, and this carbon is going to turn into a carbocation. It's going to be positively charged. So since it's positive, it's going to love an electron rich species, right? So it's going to act as an electrophile, a species that loves electrons, and it's going to attack the benzene ring because obviously it likes electrons. So this over here is going to be our electrophile. Right, now we have done acylation of benzene. Now we're going to move to alkylation of benzene, in which an alkyl chain will be added to the benzene ring. I think it's been way too black and white. Let's add some colors to it, shall we? Oh shoot. Which color? Okay, let's use orange. Done. Now we're going to see alkylation of benzene. Okay, we're going to see alkylation of benzene, and just like I said before, that for example you have CH4. You're going to call this as, it's going to be known as methane, right? But if you have one hydrogen removed from methane, it's going to turn into CH3, right? And you're going to call this not methane, but you're going to call this methyl, right? So this methyl, or you can have ethyl or propyl or butyl, right? These are known as alkyl groups. Okay, this is an alkyl, right? So in this reaction, again we're going to have a benzene ring, and it's going to react with an alkyl halide. This is an alkyl, C2H5, I already just mentioned it's an alkyl halide, or in this particular case, it's an alkyl chloride, and if you want to name it, it's going to be ethyl chloride. For example, if we had C2H5Br, then it will be alkyl bromide, right? And again, because it's a Friedel-Crafts reaction, we're going to have the same catalysts that we used before, FeCl3, FeBr3, or AlCl3. Right now I'm just using FeBr3. Okay, you can use over here FeCl3, or you can use AlCl3, and again you're going to get this product, which is going to be C2H5 plus HCl, C2H5 plus HCl, and this compound, which is our alkyl halide or alkyl chloride, chlorine is going to be removed from here, and we're going to have a carbocation over here, C3H2 positive. This carbon is going to turn into a carbocation, and it's going to act as an electrophile, right?